Okay, so now that you have seen how the axis angle rotation mode works, it's simply using a pole rotational system. We're going to take a look at quaternion. Go ahead and switch this cube to quaternion. Now, first I'm going to point out a few differences between axis angle and quaternion. So first, what I want you to do is switch this back to axis angle. Notice that the W will store the rotational values for this pole. Now, when you are dealing with quaternions, the W by default will store the rotation values for this pole. But the W in the case of quaternions does not have a special meaning that we can make any of these axes store the rotation value and then make the W store the location value. So meaning that over here, let's say we click on Y and type in 1 and enter. Go to W and type in 0 and enter. Now the Y is going to store the rotation value and the W is going to store the location value, right? So when you are working with quaternions, the W really doesn't have a special meaning. Any of these axes can store the rotation value, right? The W simply just starts to store the location value for whatever axis is now storing the rotation value. Now, of course, when you do Alt-R to reset the rotation, your Blender is always going to set up the W to store the rotation value. That's the first thing. Now, the second thing is understanding this idea behind the rotation values. So over here, if we switch this to axis angle and press the R key 2 times to rotate, let's say, this cube like this, here we can see that we have a rotation value stored for the pole. Now, when you switch this to quaternion, what you're going to get is a cosine. Okay? Now, when you're dealing with quaternions, the rotation values always have to be doubled. That's just how quaternions work. So what exactly does this mean? So this means that if we bring up our calculator, it has to be scientific. Now what you're going to do is type in, let's say in my case, I'm going to type in .980, and here we're going to get the inverse of cosine. Because we have to double rotation values, we have to do times by 2. You'll see that what we get is 22.956. When we switch this to axis angle, what we get is 23.17. The numbers are not matching. The reason for this is because there are hidden numbers inside these fields. So here, if we hover our mouse, in my case, I'm going to do Control C, bring up Notepad and do Control V. This is a larger number. So this means that if we switch this to quaternion, hover our mouse over here, do Control C to copy the value and paste it over here, Control V, this is a larger number. So now when we copy this value with Control C, go back to our calculator, clear everything out, right click on this and paste this. Now when we get the inverse cosine and now times it by 2, you will see that we get 23.169. Over here, when we switch this, we get 23.17, meaning that it's basically the same thing, right? 169. It's very close, okay? Because we're talking about floating point numbers over here. So just be aware of these hidden values in these fields, okay? And always remember that when you're dealing with quaternions, the rotation value is always doubled, okay? That's the second concept. Now, the third concept here is that you're not going to find yourself using axis angle. You're simply always going to come back to quaternion. This is because quaternions are really better at interpolation between lerp and slurp, okay? That's the third thing. So what we're going to do now is go ahead and take a look at how to make this thing that we've built to work with quaternion. Now you will notice that when we are on axis angle, click on this cube and press the R key to rotate, the pole rotational system is working. Now when you switch this to quaternion, click on this cube, do Alt-R to reset the rotation. Of course it's not going to work because now it's quaternion. So here the ball is not seeing any values coming in, so it's just going to stay over here. So to reset this, just click on axis angle, it'll snap back. Go ahead and switch to quaternion. Now what I want you to do is go ahead and open this up, go to the graph editor and switch this to drivers. Click on this ball. Of course, click on the X location, open this up and expand this and go to drivers. Look over here. Now, because we're dealing with quaternion, we have to do the same thing. Right now it says rotation axis angle. So just click on this cube and hover your mouse over here on the X, right click and do copy data path. Click on this ball, go to the X location and hover your mouse over here, do Control V. Now over here, click and type in .x and enter. Now I'm going to put this down a little bit, okay? Sometimes you'll get an error message to after you change something like this, you should click on update dependencies. We most likely will see this error message when we start changing these values. So click on the Y location, hover your mouse, do Control V, and over here type in .y and enter. You'll see that we get this error message. Just click on update dependencies. Now click on the Z, hover your mouse, do Control V, click over here, type in .z, enter, and now again do update dependencies. I'm going to put this up over here, okay? So now when we click on this cube and press the R key 2 times to rotate, you'll see that it works exactly the same way, okay? So what I want you to do is press the R key 2 times to just rotate the cube like this, press the 1 key, press the R key again and just rotate it kind of like this so it looks a bit nicer. Now we're going to do the same thing. Click on this pole, do Shift D to duplicate, right click to cancel. Notice the name of the duplicated object, do Control A to visual transform and turn off the damn track. Click on this cube, do Shift D to duplicate, right click to cancel. Notice the name of this cube. Now here we're going to go ahead and click the cube again. If we want to go back to the original cube, do Alt R to reset the rotation. So in the same way, we're just going to click on this, press the Shift key down, click on this, do Control P and create that parent-child relationship. So now when we click on this pole and press the R key, press the Z key 2 times, of course when we rotate it, the object will go back to its original starting rotation. Right click to cancel. So now when we click over here, we know that this is going to be .938, right? So here we can simply hover our mouse, do Control C to copy this value, go to our calculator, right click over here and do paste, and here we're going to get the inverse cosine, of course, times it by 2 equals, we get 40.455. 40.455 and minus and enter. You see that the cube goes back to its original starting rotation. I'm going to do Control Z to undo this, press the 1 key, click on this cube, press the Shift key down, click on this pole, do X and now delete. So you've seen how this concept works, okay? Now what I want you to do is click over here and now change this. We're going to say that, okay, we want the Y to be a value of 1 and change this to be 0. So now the Y will store the rotation value and the W will store the location value. So of course we have to fix this in the driver. So click on this ball and open this up. Now click on Y and all you have to do is change the Y to W, right? It's the same thing. Now when you click over here, press the R key 2 times, it works. Of course, if you do Alt R, you're basically breaking the driver system, right? It's going back to W to store the rotation values. So now we have to click on this ball, go to the Y location and just change it back. So be aware of this, right? When you do Alt R, it simply resets everything and your driver system will break. So the point of this here is that don't change this, right? Let the W store the rotation values. That's how this whole concept works. Now what I want you to do is go under File, do Save As, and now save this as rotation concept 17.blend. Okay, so now that you have seen how axis angle, Euler, and quaternion rotation mode works, we're going to start the module-based rigging system. So let's go ahead and set up the file so we can start this process in the next lesson. So go under File, do Open, and go ahead and open Rigging Lesson 02 L.blend. This again is the file where we had completed stage 1 of the rigging process. So what I want you to do is go ahead and click on the armature and switch to Edit Mode. Do Shift C to place the 3D cursor in the center. Do Shift A to add a bone. Press the 3 key. Now here you're going to zoom in, press the R key, press the Control key down, and rotate this by 90 degrees. Click on this bone, and over here you're going to type in root. Enter. Now when you're building a rigging system, you always want to give your rig a root bone. So the hip bone is right now acting as the root bone, so we're going to click on this hip bone, press the Shift key down, click on this root bone, and do Control P to create a parent-child relationship. Make sure you select Keep Offset. Now you will see that when we switch to pose mode and click on this bone, we can press the R key 2 times to rotate the entire character. We can press the S key to scale the entire character, and we can press the G key to move this entire character. Okay, that's the idea with root bounds. So we're going to leave this like this. Go ahead and switch to Edit Mode. Press the 1 key to go to the front view. Do Shift C to place the 3D cursor in the center. Do Control and middle mouse button and just go ahead and zoom in like this. Now you're going to go under File, do Save As, and let's save this as a Rigging Lesson 03 A.blend. Just simply overwrite this file. So I'll see you in the next lesson where we're going to start the module-based rigging system. So when we do that, everything is going to make sense to you because we are going to be using parent-child relationships, working with constraints, working with world space or local space, and of course working with our Quaternion and Euler angles. So I'll see you in the next lesson. Thank you.